Well, a very good morning to you all. As discussed in the previous presentation, today we'll be discussing about the process of power quality analysis in the software. So to begin with, this is the wind farm which is considered for power quality analysis. It's being distributed into three networks: network 1, network 2 and network 3. If I double click on network 1, I'll be able to see an enlarged view of network 1. It shows you that the network comprises of a wind turbine generator, and finally it's being having a transformer which is used to step up the voltage, and this the cables are used to indicate particular distance from the transformer to the next node. You can also observe that this is bus number 6, which is indicated here at the end in network 1. So network 1, as shown in this diagram, network 1 comprises of 6 wind turbine generators: WTG 1, 2, 3, 4, 5 and 6. So this is a squirrel cage induction generator, and it is having a capacity of 2.1 megawatt. Finally, whatever voltage is being generated, that is to be stepped up. I'm making use of a step up transformer, and finally the power is being given to the utility grid. Now this is network 1, this is network 2. Network 2 comprises of 6 wind turbine generators. Again, the wind turbine generator is equipped with a transformer of 2500 kVA, which is used to step up the voltage which is generated at 0.69 kilovolt. You can observe that in network 2 there are 7 wind turbine generators: 1, 2, 3, 4, 5, 6 and 7 wind turbine generators of capacity 2.1 megawatt. This is this is network 3. It is again comprising of 7 wind turbine generators. Finally, these networks are connected to the respective buses: bus number 6 for network 1 and 2 and bus number 7 for network 3. Now what are we going to do is, first we'll be discussing the specifications of the wind turbine generator which is used. As discussed earlier, the rated power is 2.1 megawatt. It is being operated at a cut-in speed of 4 meter per second and a cutout speed of 25 meter per second. The hub height is 100 meters. The rotational speed is in the range of 15 to 17 rpm. A diameter of 88 meters. Swept area, that is the area covered, you can also find it by pi r square, that is the area of the circle. It comes around almost 6082 square meters. As discussed earlier, the generation voltage is 690 volt. You can also term it as 0.69 kV, and the operating frequency is 50 Hz. As discussed in the previous presentation, I also mentioned that the gear ratio for the generator can be in the range of 1:98, and the average wind speed in which this generator is going to operate is 9 meter per second. The tower type is tabular. There are two types, tabular and lattice. We have been making use of tabular in terms of 4 sections, and the blade material is fiberglass. So what we'll do is we'll be first discussing what all analysis you can do in the software which relates to the power quality. The first and foremost is the load flow analysis. Now we all know what is load flow analysis. It is the analysis of a power system under steady state condition. Now this is the wind farm under consideration. You can also observe that it's being distributed into 3 networks. Under normal operating condition, under steady state condition, what is the capacity the wind farm is capable of delivering? Now you can observe that on the rated speed of 9 meter per second, network 1 and network 2 are contributing almost 26.1 megawatt power output, whereas network 3 is comprising of 14 megawatt, and further finally the power output given to the grid is 40 megawatt. The capacity of this whole wind farm is 42 megawatt. So the difference of 2 megawatt is a mere consideration of system and transmission losses. We'll continue forward.